Welcome to Spring LIB.
In this exercise, we have a turntable with a flea on it. The flea is at point A on the turntable, and point A is located at a distance of 10 centimeters from the center of the table and exactly on the x-axis. The frequency of the turntable is 33.3 revolutions per minute, and exactly when the point A passes through the x-axis, the flea jumps from point A originally to point B, and as the flea jumps, point A rotates a certain angle theta, and our goal here is to find what are the coordinates of both point A and point B, given that the flea jumped a height of 5 centimeters, and that the fleet had no horizontal velocity with respect to the table. So in question A, we have to find what is the position of the point A. So the position of point A is R0, which is the radius of point A. That's the distance of point A from the center of the turntable, and it doesn't change, times the cosine of theta I minus sine of theta j. And notice that theta is equal to the angular velocity times the time t, or 2 times pi times the frequency times the time t. And since the frequency is 33.3 revolutions per minute, that's the same as 0.556 hertz times t. So this is 1.11 pi times t. So Ra is 10 centimeters times the cosine of 1.11 times pi times t minus sine of 1.11 times pi times t in the y direction. And what we need to do is to find how much time does it take for the flea to jump from point A to point B, so that we can plug the time t into Ra, and then we can find exactly the position of point A. So notice that the flea jumps at a maximum height of 5 centimeters, and the total time of the jump is equal to 2 times the time it takes for the flea to reach its maximum height. So let th be the time it takes for the flea to reach its maximum height. So we have that the time t is equal to th. So let's calculate what th is. The flea jumps in the z direction, okay, and we can calculate, and the initial, actually, let's write it like this. The speed in the z direction is equal to the initial speed in the z direction minus gt, okay, because the gravity is pointing in the z direction, when the flea is at its maximum height. Vz is 0 and t is th. Okay, so gth is equal to v0z. And also from Torricelli's formula, we have that vz squared is equal to v0z squared minus 2g times delta z, when delta z is equal to h, when the flea is at its maximum height, vz equals 0, and we have that v0 z squared is equal to 2gh. Okay, but v0 squared is also equal to g squared th squared, and for that reason th is equal to 2h divided by g. T squared is equal to 2h divided by g, and for that reason th is the square root of 2h over g. So this is the square root of 2 times 0.05 meters, that's 5 centimeters, divided by 9.8 meters per second squared. So th is equal to 0.101 seconds. And for that reason, t, which is 2th, is equal to 0.202 seconds. So let's plug it in RA. RA equals 10 centimeters times the cosine of 1.11 pi times 0.202 I minus the sine of 1.11 pi times 0.202 j, and this is equal to 7.62 I minus 6.48 j in centimeters. So this is the answer to question A. And in question B, we have to calculate the position of the point B. Notice that initially the flea is on the x-axis. Okay, he is on point A, that is moving in the y direction, in the negative y direction. Okay, so the speed of the flea, the initial speed of the flea is in the y direction, given that relative to the table, to the turntable, the flea doesn't have any horizontal speed, so the speed is just the speed of the turntable itself at the point where the flea jumps. Notice that throughout its trajectory, since there is no velocity there is no x component to the velocity, the flea doesn't change its x component. Okay, so the x component of RB, which I'm going to call RBX, you already know, that must be 10 centimeters. And now we can calculate the y component of the flea when it lands. Notice that the speed of the turntable at point A is equal to 2 pi f times r. That's the angular frequency times the radius. So this is 2 pi times 0.556 hertz times the radius, which is 0.1 meters. So the speed v is equal to 0.35 meters per second. That's the speed in the y direction. Okay, but it's pointing to the negative, in the negative direction. So y is equal to minus vy times the time t, and we already calculated the time it takes for the flea to complete its jump. So this is minus 0.35 times 0.202 in seconds. So this is minus 0.07 meters. So the final position of the flea, RB, is 10 meters in the positive, 10 centimeters. And here we should also here should be in meters, and this is equal to minus 7 centimeters. So the final position RB is 10I minus 7J in centimeters. And this concludes the exercise.